All right, here we're trying to find the derivative of 1 over x plus 3. So let's just throw this right into the derivative formula here. So we have the limit as h goes to 0 of f of x plus h. And in this case, that would just be x plus h plus 3. And then f of x is obviously just 1 over x plus 3. And that's all over our h. Now, with all of these equations that have these rational functions, we have this complex fraction. What we're going to do is multiply the numerator and denominator, this larger fraction here, by basically just the denominators that we see. It's really the least common denominator is the fastest way, but the least common denominator in this place is just that. And when we do that, let's see what we get here. This always will work out well if we multiply by the right thing. So we have the limit as h goes to 0. When I multiply this into that factor, the first factor of x plus h plus 3 cancels, and I'm just left with this x plus 3. And then minus, when I multiply this into the second one, the x plus 3's cancel, just leaving me with this x plus h plus 3. And in the denominator, I just multiply all of this stuff together, x plus h plus 3. And then times x plus 3. Okay, so we're now going to clean up this stuff in the numerator here. What we're going to do is to get in this numerator is x plus 3, now minus x minus h minus 3, all over that stuff in the denominator. And I'm just going to do this cheaply and quickly. All right, and then we get is some canceling here up in the numerator. The x's cancel, the 3's cancel, and I'll just do this quickly too. This is the whole reason for us doing these above steps is now all I'm left with in the numerator is that negative h. That negative h, or specifically the h, will cancel with the h down here factor. We're just left with a -1 up there in the numerator, which now gives us the limit as h goes to 0 of -1 over x plus h plus 3 times x plus 3. We now can plug in our value here of 0 for h because our denominator is not going to go to 0. So we plug that in, and that just makes this term 0. And what that is then, we've evaluated the limit. We don't have, oh, I forgot that negative back there. We have -1 on top, and then we just have x plus 3 times x plus 3 in the denominator. And we could just one last little thing here. We could just multiply those together or just clean it up, simplify to be x plus 3 squared. So what that is the derivative of our original function there. Again, to just quickly review what we did in those steps, here is the classic move. We're taking care of the complex fraction by multiplying by the denominators we see in those fractions up there in the numerator. Once we've done that, our goal is to get to this point where we can cancel that factor of h in the denominator. Again, the reason we're looking to do that is the reason we did all of this. We couldn't plug 0 into h originally because it would make our denominator equal to 0. We know we can't do that with limits. But once we get that factor of h canceled, we can then just plug it right in, and we have our final version of this derivative.